Hi, I'm Mrs McTaggart. In this video we are looking at the third level topic of angles. In particular we're looking at corresponding angles, which may also be called F-shape angles. Our lesson intention is to be able to calculate missing angles using the corresponding angle properties associated with intersecting and parallel lines. Now that might sound like a lot of jargon just now, but it's not too bad honestly. Prior knowledge to this is you should be familiar that two angles in a straight line, for example, like this, always add to 180. It might also be handy to be familiar with opposite angles being equal and angles adding to 180 in a straight line. So what happens in maths is when you have two parallel lines and that are being cut by a straight line, corresponding angles are said to be equal, and we look for F shapes. So let's explain what this means. So in this diagram, you've got these two straight lines and they've got these little arrows on them. In maths, that means that these lines are parallel. And parallel means that they are running at the same direction, the same width apart. Think of train tracks. They're always the same width apart no matter what direction the train tracks are going in. So they are parallel lines. So look out for these little angles. The minute I intersect that with any straight line, now it could be going this way or the way I've shown in the diagram, we look for F shapes. Now F shapes can be front as a normal F shape, like I've shown in red up here. They can also be back to front, like I'm showing you now in blue. They might also even be upside down. So we could even have an F shape going like this. And it all depends what kind of angle we're asking you to find in the question. Now what happens with F shape angles is the ones that are corresponding are the ones that match up together and they are in the same position, for example, directly below the parallel line and to the right. So these ones I've shown with the green dots are corresponding angles. Look at the positioning of them. They're both directly below the parallel lines and they're both to the right of this big intersecting line. So they're both to the right hand side of this intersecting line here. So they are corresponding. But that also means that if I look at my blue F shape down here, this one here, if I slide that down, this corresponds to this one here. So that is called another corresponding angle. So the ones that are trapped inside the F shape in the same position as each other are corresponding. But there's actually a bit more going on than that if we think about prior things you have seen. If you have seen opposite angles, we also know that these two are opposite, so they match. And then all these other ones must match. So the ones that I'm now colouring in red are also matching angles and they're also corresponding. So this diagram here of three straight lines actually only has two numbers going on in all these missing angles. But we need to spot the F shapes, and if you don't spot them, it gets a wee bit tricky. So let's look. So here are two examples. My first one is clearly just an F shape. So let's try and think, where is a corresponding angle here? Where is the one that matches up with the 100? So what I've got is I've got an F shape almost lying on its back here. So here is the F, if you were to tilt your heads or spin the screen around. So look at the positioning of the 100. Where else is going to be the same? So that 100 is to the left of the parallel line. So to the left of the other parallel line, here is your other 100. And notice it looks like it's just slid along to the right. And in fact, if I then continue this and do another parallel line, this one here would also be 100. Or if I do another one down here, this one here would also be 100, always to the left of your parallel lines. So let's take this away and go back and think there's one more missing angle in this diagram that I need to fill in, and it is the one to the other side of the 100. So these two here are both on a straight line. They both must make 180. So 100 away from 180 makes this one in here 80. And that is me completed all the missing angles in that diagram. Right, let's look at the next one. Do I have an F shape? Yes, I do. I have an F shape going on here, so I'm going to do it in green this time. So here is my F shape, but it's going back to front. Now I don't have any angles in my F shape to start me off. However, I do have an opposite angle. So this one and this one both match. So that one and that one are both 115. And I'd think, right, which one matches with that 115? So actually, this is above the parallel line. So above the parallel line here is also 115. It's like it's just slid up a little bit, which means the two missing angles that are under the green F, so these two here, both must also match. And they're on a straight line, with 180 each time. So 180, take away 115. You can either do take away by parts, you can do a little sum. I'm going to add up. 5 would take me to 120. 60 would take me to 180. So these two missing angles are 65. Okay, and essentially what's actually happening, I don't know if you notice this, but this whole angle down here has literally just slid up to that whole angle there. And if I extended that line, this would also be 115. This would also be 65. And I've just noticed I missed out an angle here, which was also 65. So although I'm introducing these questions through F shapes or corresponding angles, there's also that prior knowledge of opposite angles going on as well, and angles in a straight line everywhere we look. So let's look at two more trickier examples. This one on the left is your dream question. If I was to put this in a test, this is the one I would be putting in, and I'd ask you to fill in all the missing angles. Now we know there is only two possible numbers going on here. So what a lot of people like to do is like to fill in all the 88s first. Now this lesson is about corresponding angles. So the one I'm going to fill in first may not be the one you would fill in first, okay? We all see angles a bit differently. I am looking for my F shapes. So I have a backwards, upside down F shape here, which I'm colouring in red. So the one that matches up with this 88 is slid down to here. So this one is 88. Now I'm going to use the fact that there's lots of opposite angles going on. So these two here are also 88. And then all these four other missing angles are the exact same. They are what make 88 up to 180, because that's a straight line. Or I could look at this one here and think, right, what makes 88 up to 180? So 180, take away 88. Well, if I take away 80, I'm at 100. Take away another 8 leaves me 92. So all these missing angles in this diagram are 92. So really, all I had to do there was one sum, and it was taken away from 180. Now this next one is a really common question which we see in textbooks and worksheets, and I quite often put them in homeworks, and some people really struggle with them. What they look at and think is this capital A and start going, okay, this is 68, this is 116, and they think it's symmetrical. Now I'm sorry, that is not a symmetrical shape, is it? So it's not symmetrical. If it was symmetrical, there would be a wee bit more information on the picture, such as maybe some lines to show that they were like lines like that to show that these two sides were ideally part of an isosceles triangle, but they're not there, so there is absolutely zero symmetry. So what we do for this one is we treat it like a left hand side and a right hand side. So if I just focus on the whole left hand side just now around this 68, where is my other 68? So let's highlight the F shape. So we've got a upside down F shape going on over here. So the other 68 is above the parallel line, so slide that 68 up and put it above the parallel line. Now, although these diagrams are never drawn to scale, it's always worth just noticing, I would never put the 68 in here, would I? Because that's an obtuse angle. So although they're not to scale, if it's an obtuse angle, I would put in an obtuse number, bigger than 90. So the 68 has to go in the other acute angle space. And then the ones below the 68s, I'm going to use the fact of straight lines. So these two angles here need to make 180. 180, take away 68, takes me to 120. Take away another 8 is 112. So these two underneath the parallel lines are 112. Now, I'm missing out some of my degree signs here. I do apologise. Now I'm going to flip over and I'm going to look at the right-hand side. So F shape on the right hand side is, it's actually going like this. So this one and this one. So if I look at the 116, it is below the parallel line this time. So the other 116, I'm going to slide it up and put it below the parallel line again. And then we know the ones above the 116s need to make it up to 180. So they must be 64 each. And there's 64. Now there's one angle missing, and you may or may not have seen this video yet, but that missing one up the top is part of a triangle, and triangles also add to 180. 180 seems to be the magic sum in angles. So to get that last angle, I need to add up the ones in the triangle, which take me to 120, 132. So the one at the top is 180, take away 132, which makes that 48. So the missing angle at the top of the triangle is 48. And that's relying on you knowing angles in a triangle. Though that one has been really tricky, but remember, it is not symmetrical. So this would be part, if you want to practice some of these, you could pause the video and try some of these ones for yourself. I would recommend sketching them and filling in all the missing angles. And then if you unpause, here are your answers. I hope this has helped. Thanks for watching.